Alright folks, quick video today coming down the stretch. In fact, this is going to be your last video, so here we go. We're going to make this short, sweet, to the point. We'll wrap up some stuff on global climate change on Monday. We will then do a little bit of optics and discuss the final, and you made it. So we talked a little bit about feedback mechanisms. The idea that if we get a little bit of warming in the climate, does that lead to more warming, a positive feedback, or does it start to induce something else that turns the warming around or turns into a cooling effect? And so we'll talk about different climate feedbacks. We got our greenhouse gases. Carbon dioxide is the one most people are very familiar with, but a number of other things behave as greenhouse gases. You see water vapor and methane here. There's other ones, nitrous oxide and chlorofluorocarbons. There are a number of different things that are going to help to trap in that moisture, but also can have impacts on, for instance, how much of the incoming sun energy gets reflected. We briefly talked about that with regard to water vapor the other day. Snow and ice cover is one of the more critical things with regards to a positive feedback mechanism when you combine that with sea ice. Clouds are a really tricky one. In many ways, clouds are what make a lot of our projections of future climates a little suspect. The fact that warm air holds more moisture, that may create more clouds, and what do the clouds ultimately do? More of a negative feedback. The thermohaline circulation that we alluded to earlier, and again, what is covering the Earth? Do we have desert? Do we have deep forests? What exactly is covering things, and how does that relate to things such as albedo in the atmosphere? And so if we look at greenhouse gases, you can see a few of them here: the carbon dioxide, the methane, and the nitrous oxide. And so what we get here is a combination of stuff from taking ice core samples and other types of deeper layer portions of the ground to get a little information, but a lot of it comes from the modern data. For instance, carbon dioxide, we're taking some regular measurements in Hawaii that give us this idea of both an annual cycle to carbon dioxide, but this pretty steady increase over the last 70, 80 years. What you can see is a relatively sharp uptick, particularly there in the inside of the graph, showing a steady amount of it from 10,000 years before. Again, you're looking down on this far bottom here to show 10,000 years prior to 2005. Pretty steady, mild increases, and then whoosh, really sharp within the past couple hundred years. And again, really concentrated in the past 70, 80 years. Methane's actually leveled off for the most part since 1990. Methane is still one of these gases that becomes an issue. A lot of it gets related somewhat fairly, but also somewhat unfairly to cows and other things that are more prevalent in today's society due to human consumption and other reasons. But there's also a lot of methane that is trapped in sea ice, and that's one of those greenhouse gases that, should we melt more and more of our polar ice caps, we potentially release a lot more methane into the atmosphere. Nitrous oxide, another one that's seen sharp increases as of recent. And so these are all, again, going to effectively help to keep that infrared energy leaving Earth's surface down by the lower atmosphere, so leading to an overall warming effect. We don't know what's going to happen moving forward. There's a number of things related to deforestation that could impact carbon dioxide. Again, how do the seas, the oceans, which actually absorb a lot of our carbon dioxide as well, how do they behave? How do things such as methane with regards to being a little bit better in terms of releasing it in the atmosphere? And so we have estimates, but not guarantees moving forward. Sea ice, what you see here are some examples with an orange line being the median for a 21-year period up to 2000, and then a little bit about how things would have been in the middle of 2015. And so you can see here the winter time on the left, February 2015. You can see a point there for the North Pole. And you can see in wintertime how there's been some erosion in areas surrounding the North Pole of where the sea ice might be. What you also can see, though, is that if you look down towards summertime, September 2015, really a large portion of it has been eroded in terms of what we get in what would be considered the summer or the warmer season there at the North Pole. And so this Arctic sea ice is going to reflect that incoming solar energy. The fact remains is that as we lose sea ice, we reflect back less of the sun's energy, which therefore leads to more melting of sea ice. This is one of our strongest positive feedback mechanisms, and definitely a concern both in terms of warming the atmosphere and also rising sea levels for a lot of vulnerable populations and coastlines around the world. Here you can see just the general uptick in terms of land and ocean temperature anomalies. So going back from 1880 to the mid-2000 teens, you can see that again, not every single year is showing an overall increase. The black line on there, this should look pretty familiar, some different years to what you have on your assignment number 5. But you can see the regression line showing that we're warming through this trend at about 0.65 degrees Celsius per century. A lot of negative relative to the overall mean years that were been in the early portion of the period. You can notice some cool periods around the 1970s as well, the most recent time in which temperatures were a little cooler than the long-term average. But you can definitely note, especially since 1990, the sharp increase in temperatures that we're seeing when we average out everything over both the land and the ocean worldwide. And so what we'll do here really quickly is just look at a little bit of what happens year to year. Here you can see these are anomalies for winter time. So this would have been a winter of 2016. So December, January, and February moving into the year 2016. And each of the pixels on these maps is going to be either red indicating a positive anomaly, meaning warmer than average, or blue, where you're going to have cooler than average. And you can see the respect to a 1981 to 2010 base period, that's what I've brought up a couple times, is going to change here literally this upcoming week in terms of our 30-year climate average. What you can see in these maps is both that not everywhere is warming every single year, but you can also notice that some of the more intense warming ends up being in the northern hemisphere at the higher latitudes. 2017, areas of the United States and Canada relatively warm, but definitely cool in the northwest. And some areas over Russia, pretty cool. 2018, 19, and of course I thought 2020 was in there, but I must have the slide hidden. Here we can see though that even on a year-to-year basis, things change quite drastically. We have two maps here, March 2013 and March 2012. We'll start class on Monday actually looking at the hyperlinks. And what you can see here though is that in 2012, basically everywhere east of the Rockies was vastly above average in terms of temperatures. If you're from anywhere around Chicago, you may remember, now it's getting to be about 9 years ago, so you would have probably been back in grade school. We had a series of temperatures in March where series of temperatures in the middle of March in the mid to even upper 80s. We had temperatures I think as high as 87. We'll take a look at this around March 20th. And so I think about 8 consecutive record high temperatures were breached, and this was one of the warmest Marches on record for many areas across the eastern United States. However, 1 year later, and it was very, very cold, March of 2013. Again, we'll spend a little time on this, but this is to, again, impress upon you the idea that not every single year is actually warmer than the preceding year. That doesn't mean that the Earth is not overall warming. It doesn't mean that we aren't concerned with trends, but it does mean that variability, weather, can dominate things in short-term periods. And that's definitely something that we want to keep in mind moving forward as we complete the section on global climate change, and also just in general as we move forward from this class. Well, I promised you I'd keep it short. Let's keep it short, 8.5 minutes. Hopefully you have a chance to watch this before Monday. We'll wrap this up. Have a good weekend and enjoy some of the warmth. Take care.